Hi, I'm Mark.
I'm Rob. We're from VPG Transducers, and today we'd like to talk a little bit about load cell technology. We are at the micro measurement strain gauge facility in Wendell, North Carolina, using their strain gauges on our load cells. And Mark, could you tell us a little bit about this load cell today?
Sure. Load cells are really unique in that they are truly an electromechanical device. And what I mean by that is the load cell itself is really a mechanical beam. The mechanical beam is going to deflect a given amount under a given load. And it's all calculated by the amount of deflection material that's left, as well as the mechanics and materials of the aluminum or the steel, alloy steel that we use in the construction of it. So we need to find somehow a way to convert that mechanical deflection into a usable signal. So what happens is strain gauges are placed on the back of the load cell or the top of the load cell, depending on the design, in a Wheatstone bridge. As the load cell deflects under load, the strain gauges themselves change their resistance as they're loaded as well. So this gives you a millivolt per volt signal that's leaving the load cell that's directly proportionate to the amount of force that's being applied. So what this does then, it changes a mechanical deflection into a usable electrical signal. So there are three things that we look at when we define accuracy: nonlinearity, hysteresis, and repeatability. What this refers to, first off, is the nonlinearity, how linear the load cell is going to deflect, and how linear that output signal is going to be from 0 to its full scale. Hysteresis is defined as 50% of ascending on its output versus 50% of descending on its output. What happens is because it's a mechanical beam, the load cell is a little resistant to bend on its way up, and it's a little resistant to return to its original form on the way down. So that center, it kind of forms a football shape in the middle of the performance parameter. So that's referred to as hysteresis, that center measurement. And then repeatability is, of course, repeating with the same given amount under the same given load over and over and over. This is a very small load cell. This is a 3 kilogram, kind of the little brother of what we do, but it gives an example of how small things can be, and they also can go up to tons in capacity. So I hope that explains a little bit about load cells and how they operate. We're certainly not limited to designs that we have on hand. We can design anything to fit within any type of machinery, medical equipment, agriculture, and construction.
Thanks, Mark. For any questions about anything that Mark talked about or any of the VPG Transducers load cells, please contact us at vpgtransducers.com. Thank you very much.
See you soon.